Welcome to Web Handling. My name is Dave Roysum. I'm super excited to begin a new series on zero, which is not nothing. It is something entirely different, as we will see. In this first episode, we will discuss calibration of load cells, including failure to replicate zero and shift of zero. So here is where we're going in this short series. In this episode, we will begin with what may be the most familiar web handling sensor, load cells. They must be calibrated upon installation and regularly thereafter, depending on reliability considerations. In the following two episodes, we will introduce a new concept. That is, zero in web handling may be different than zero on web machines. We will illustrate this concept with a lay-on roller and with motor torque. That would complete the tour of the TNTs of web machine control. Without going into application-specific details, we note that load cells are calibrated by hanging weights on a strap that follows the web run in that local area. We first set the zero with a weight set at zero. Then we hang a weight near the maximum rating of web tension or the load cell, and then we set the gain. Finally, we take the weights off and recheck zero. It is not unheard of for failure to replicate zero and gain. While this is possibly a problem with the load cell, its amplifier, or other adjacent components, it is even more likely to be a procedural error. The most common is for the test to have too much friction. The most common way here is that the strap is routed over a high friction element, such as a motor-driven roller. This is a no-no. You must add a pulley to just barely clear the high friction element to take it out of the calibration procedure. Those interested in the details of calibration should review my episode on dancer calibration, which is the most popular episode on this channel, receiving more than 14,000 views. In short, dancers and load cells are calibrated for the same reasons, in the same units and using the same procedure. Any difference in the practice of calibrating load cells, but not dancers, is merely a cultural handicap. Every operator should be taught to check the zero of the load cell once a shift or when feasible or possible. This is quite easy. When the web is off or loose, the tension should be zero. And so too should be the load cell reading. If not, maintenance should be called. This is analogous to checking fuel level in your car before driving away, or in much older days, checking the oil also. Now before we move on, I should add a side note of caution. That is, even if the gauge reads zero, you may not be seeing a negative tension if that were what the load cell was erroneously putting out. For example, most amplifiers will not put out less than zero. For example, most analog gauges do not go below zero. For example, most PLCs have an upper and lower limits sprinkled throughout their programs. A lower limit of zero is common. Moving on. So the first time the operators see a zero shift, they should call maintenance. Maintenance responds by re-zeroing and possibly calibrating gain. If you see one failure, a second should not be surprising. Maintenance again responds by re-zeroing. However, the third time this happens, the proper response is not to repair or replace, but rather redesign. That is because the load cell or amplifier is not trustworthy in this application. Re-zeroing a load cell is much like putting air into a flat tire. You know that the tire is going to go flat again because the root cause leak is still present. Pumping up the tire or re-zeroing the load cell should be only an emergency, temporary procedure until the tire can be patched, replaced, or the load cell redesigned. I hope you have enjoyed this introduction to zero. Stay tuned for next week when we will complicate the meaning of zero by introducing the concept of web versus machine units, as well as how to deal with ubiquitous system friction. We will use nip roller pressure as an example. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful, please like and share and subscribe. See you next time.